Before we start on this topic of arcs and sectors, obviously it's important that we know what an arc is and what a sector is. So in the diagram here you can see both of these things pictured. We'll go through some of the more basics of a circle first. Just to remind you of, for instance, this point here will be the centre of the circle. This line here, this is a radius because it goes from the centre to the outside. If I was to extend this line going down this way, I would have a diameter which goes from one side of the circle through the centre straight to the other side of the circle. And then we would have normally the circumference of a circle, which is the total distance around the outside of the circle. Now, two other terms then we need are arc and sector. The arc is basically part of the circumference. So the circumference of a circle is the total distance around all of the circle, whereas an arc is just the distance around a part of the circle here. So an arc is just a part of the circumference. The sector of a circle is just two radius joined obviously to the centre because of the radius, and it's this shaded area here. First thing we're going to look at is how we find the arc length of a sector using a formula. Now, remember arc length, or the arc, is just a fraction of the circumference. So the whole circle has a circumference, and this little bit here, this curved part, is just an arc. So what we want is, because the formula of the circumference of a circle is c equals pi d, I'll remind you that was right up the side, c equals pi d, that's how I'd find the circumference of a circle. You can see that here in your formula. This part here is the circumference. And what we've got here, this angle over 360, is just telling us what fraction of the circle we have. So for instance here, if I had 23 degrees here, then I would have 23 360ths of pi d. So a reminder in the formula that d stands for diameter. So we'll have a look at this question here and we'll try it. Now, the first thing with these questions is when you're asked to find the length of the arc or the arc length, first step is to always write out the formula. So arc length is equal to angle over 360 times pi d. And all we then have to do is to look at the formula and start to fill in all the parts we know. Now the arc length is obviously the thing we're trying to find in this question, so that's going to remain as arc length. We're just going to leave that as it is. Angle, well, the angle is 24, so that can be filled in, so it's equal to 24 over 360. And then multiplied by, it's pi times d. Now pi is a constant, so we know the value of pi is round about 3.14, but we're going to use the pi button on our calculator for a more accurate response. And d stands for diameter. Now anytime you're asked for radius or diameter in a question, you always got to be careful to make sure you've actually been given the correct one. So remember, this is a sector of a circle, which means if the whole circle was drawn, this would be the centre of the circle. Now if this is the centre of the circle, that 7 there is the radius of the circle. So that's not what we're looking for here, we're looking for the diameter. So if the radius is 7, the diameter is 7 plus another 7, or 14, two lots of 7. So we're going to put times 14 there. Now when I type that into my calculator, all I need to do is make sure I understand what's happening here. So 24 over 360, if you've got a fraction button in your calculator you can use it. If not, it's just 24 divided by 360, that's all you're doing there. So 24 divided by 360 times pi times 14. And what we end up with is 2.93. No, 2.93. And what we're looking at again is what type of unit should we be using there. So this is arc length. Now because it's a length, that means the unit will just be, in this case, centimetres. We don't need to have square centimetres, that will only be for area, or cubic centimetres, that will only be for volume. So a length will be centimetres. And that's basically the length from A around this curve to B is 2.93 centimetres. Now occasionally in a question you'll have a whole circle drawn and you'll be asked for an arc length. So the question then becomes, which arc are you looking for? So in this case there are actually two arcs shown within this circle. There's a major arc and there's a minor arc. Now major and minor, you would associate that with the major being bigger than the minor. So the major arc is the longest distance between A and B. So if I go from A to B, I can do it two ways. I can go the shortest way or I can go the longer way. Now the major arc is the longer of those ways. So in this case, A to B, the major arc A to B is this length here. Now if I'm wanting this length here, the major arc, I need to use this angle here. If I'm looking for the minor arc, which is the shortest distance from A to B, then I would use this angle here. Now here in this case I've used a Greek letter to represent each of these angles. You don't need to know about these, you don't need to be able to write them or know how to say them. This is theta and this is phi. So major arc length in this case, using the bigger angle, I would end up with phi over 360. Phi is just whatever representing that larger angle, times pi d. And for the smaller one, the minor arc length here, the smaller arc length, it needs the smaller angle to go with it. So that's going to be theta over 360 times pi d. Here are two questions for you to try yourself. Pause the video, try the questions and press play when you're ready to go over them. Okay, first question here, we are asked to calculate the length of the arc BC. So the arc BC is this curve here, and we're given the angle 42 degrees and a radius of 12 centimeters. So first thing we're going to do is write the formula here, which is arc length equals angle over 360 times pi d. And again, I'm just going to go and fill it in bit by bit. So we're looking for the arc length, so we'll leave that just now. The angle is 42 degrees, so that becomes 42 over 360 times pi multiplied by the diameter. Now remember, d stands for diameter. So again, when you're using radius or diameter, always double check that you've got the right one. Now, this is the centre of the circle. If the whole circle was here, it would be all the way around like this. So this is the centre, meaning OB here is a radius. That's not what we're looking for. We want the diameter. The diameter is always double the radius, so the diameter here will be 24. So we'll put that in here and type it into your calculator. When you're typing it in, remember, if you've got this but you have the wrong answer, it might just be an issue with how you're typing it in. So you do 42 divided by 360 times pi times 24 and press equals, and you end up with 8.80. If I round it to two decimal places, the calculator actually says 8.7964, but we're going to round that to two decimal places. The unit here is centimetres, so because this is a length, that's going to be centimetres there as well. The next question here asks us to calculate the length of the major arc. Now, underline major arc, let's just look out for things like that. There are two arcs on this because we've got the whole circle drawn. There is the arc going this way, and there is the arc going this way. So this is obviously the smaller one, so this is the minor arc, and this one going this way is the larger of the two. This is the major arc. Now, if I'm going to find the major arc, then what I'm going to first of all need is I'm going to need the major angle, the bigger of the two angles, which is the angle that you can see me kind of highlighting here. Now, there are 360 degrees in a circle in total, so if I do 360 take away 120, that leaves me with 240 degrees. So what I can do is I can then fill this angle here in as 240 degrees. Both of those should add up to 360. Now I have the angle I need to find the major arc length, and then it's just a case of sketching out the formula, which is again arc length equals angle over 360 times pi d. And again, filling that in, we remember we're looking for the major arc here, so we're looking for this arc, which means I have to use this as my angle, the major angle, so 240 over 360, so 240 over 360, multiplied by pi, multiplied by the diameter. And again, sometimes you're given the diameter in the question, it might tell you, up in like the text of a question, it might say the diameter is. But in this case, we're given this line here, which is 8 centimetres, but it's from the centre to the outside. So that 8 there is actually the radius. So we need to make sure that we double that to get the total distance across the way, which is the diameter. So 8 times 2 is 16, so pi times 16. And then that goes into our calculator, and we end up with 33.51. And again, because it's a length we're looking at here, it's going to be in centimetres, so matching up our length unit there. And that's basically it.